So I wanted to go over an example of how to factor a polynomial that was not a trinomial, that wasn't something with a four-term polynomial that could be factored by grouping either, just to kind of give everybody an idea of what's expected there on this kind of problem. So those higher degree polynomials are trickier to factor generally, yes, still totally doable though, okay? So for this particular example, asking you to factor the polynomial, giving you the polynomial f of x is equal to x to the fourth minus 3x to the third minus 6x squared plus 28x minus 24. And so what the book is intending for you to do, or what the homework is intending you for you to do, is to remember that if we factor out, if we take all the numerical factors of our constant of 24, technically negative 24, we have plus and minus 1, plus and minus 2, plus and minus 3, 4, 6, 8, 12, and 24. So combinations of positive and negative, 1 and 24, 2 and 12, 3 and 8, 6 and 4. These are all the numerical factors of this value of negative 24. So it has a whole bunch of factors. And then we also have to take the factors of the coefficient here. Remember, if there's no number, it's an implied 1. So that's easier, only plus and minus 1. And so they tell us in the book that if I take a combination or a rational quantity of one of these factors over one of these factors, that any of these numbers in this list are possible rational solutions. Unfortunately here, that gives us a lot of possibilities. Any of these over 1 will continue to be themselves. So this list of plus and minus 1, plus and minus 2, plus and minus 3, so on and so forth, these are all my possibilities for possible rational solutions. And there's no guarantee for these kinds of polynomials that I'll even have rational solutions. So at this point, if we didn't have technology, the intention would be for you to just start plugging away at it, tossing in different possible values to see if they do divide out evenly. I would recommend synthetic division for that, and to see if you can start to pull this polynomial down to a lower degree polynomial that will factor for you. So that gives me a lot of room for error, unfortunately. And so one of the things that we often suggest people do in this situation where you've got this huge list of possible rational solutions and you have a polynomial that's not really working as far as grouping might go, sometimes we recommend to students to go ahead and just graph this. Use either a graphing calculator, use some free graphing software online like Desmos. There's others as well if you don't like Desmos, to kind of give you a starting point to see, hey, I'm looking at my graph and I'm seeing that it's either touching or crossing the x-axis at this particular x value, and so I'm going to go ahead and see if that works as a solution. Because remember, solutions are the same thing as x-intercepts for us graphically. And so if I had done that, I would have seen that positive 2 is a solution for this particular function because it does have an x-intercept at x equal to 2 if I graph it. And so that's a good starting point. So I'm going to go ahead and put 2 and just start to tear this apart using synthetic division. So 1, negative 3, negative 6, 28, negative 24. And then go through our process. So 2, then negative 1, negative 2, negative 8, 16, negative 16, then that gives me 12, 24, and 0, so that works. If I were to look at the graph, I would see that there really aren't a whole bunch of x-intercepts, and so I might try using 2 again, just because of the way the graph's shaped. So again, this kind of relies on us looking at a picture of the function to start factoring it rather than relying solely on this list of possible rational zeros. So 1, then 2, then negative 1 plus 2 will give me another 1, then 2, negative 6, negative 12. I no longer need this because remember that's our remainder area. and this gives me 0, so that one works as well. So far I've got factors of x minus 2 and another x minus 2, and when I've done that, it was a 4th degree polynomial. Here these were the coefficients for a 3rd degree polynomial. Now these are the coefficients for a 2nd degree polynomial. So this polynomial I started off with, this x to the 4th minus 3x cubed, so on and so forth. So far, because of what I've done with my synthetic division, and also by looking at my graph and checking it against my list of possible rational solutions, I know that this polynomial can now be written in a different format. I can say that my function is equal to x minus 2 times x minus 2 times x squared minus, plus x minus 6. Now that I've got this down to a quadratic, I'm going to go ahead and try and factor this quadratic. If I want two numbers that multiply to negative 6 and add up to positive 1, well, that would have to be 3 and negative 2. So my factors are going to be x minus 2, x minus 2, x plus 3, and x minus 2. So this is what it looks like all drawn out. And then we usually ask that you shrink that back down using your exponent notation. So we would have x minus 2 to the 3rd power and x plus 3. So there's no fast way of doing it purely algebraically without the use of a graph, which is also algebraic, but there's no way of doing it really in a faster method. You can't really sort of reverse FOIL it like you can a trinomial. I hope that helps. Please keep sending questions.